Hey everyone, Sebastian here, back again with more SAT math. I got another core class video for you. This is 23 questions on scatterplots and modeling and two variable datas, which is a category within the broader category in the SAT math section on data analysis and problem solving. So we're going to be doing a lot of charts, a lot of conceptual thinking, and actually not that much calculations. So we'll start with the easy questions like I've done before, move on to the medium, and then go to hard. All right, so we have this beautiful one here. Which of the following is the best model for the data in the scatter plot? And we have this multicolored scatter plot that we're working off of. So first of all, let's look at the differences between the answer choices. That's what I like to do. So we have negative 21. Let's do something simple, the y-intercept. Negative 21, positive 21, negative 21, positive 21. So it's going to be one of those two. It's clearly more likely to be positive 21 than negative 21, so eliminate A and eliminate C. Now we have left 2x squared minus 12x plus 21 and x squared plus 12x plus 21. It might be tempting to focus on the 2x squared and the x squared, but focus on the minus 12x and the plus 12x. And let's just plug in a value, right? Let's plug in 1. If we plug in 1 in B, we're going to get 1 squared, so that's going to be 2 times 1 minus 12 plus 21. So that's going to be 2 minus 12 is negative 10 plus 21, that equals 11. So it's going down, which makes sense because this is going down. If we did it in the other one, we would do 1 squared plus 12 times 1 plus 21, and that would be 34. So this one would actually be facing down, actually. If we think about the plus 12x, it's going to be a shift if we figured it out. Shift to the left instead of to the right. So our answer should be B. And you can see that simply by plugging in and seeing what happens with them. You don't have to think about the slope aspect of the 2x squared. This is the thing that's really making the difference there. And yeah, it's perfect. It's an easy question, just sort of leaning in. It's actually probably one of the harder easy questions, if that makes sense, but still overall easy. All right, so here's another one, scatterplot EB. It's all about interpreting a scatterplot here. On a certain hot day, someone tracked the temperature in the room every 30 minutes starting at 6 a.m. The graph to the left shows the temperature in degrees Fahrenheit of the room. During which of the following 30-minute intervals does the temperature of the room increase at the greatest average rate? So we just look at these dots. So every 30-minute interval, when does it jump up? Instead of trying to look at all of them and find the biggest one, let's compare. So 0 to 30. Okay, there's that jump there. 120 to 150. Okay, those look pretty reasonably the same. 210 to 240. Okay, that looks a little bigger. And 300 to 330. Okay, that's clearly the biggest jump. On a question like this, it shouldn't be, ooh, what's the closest? Ooh, close. No. It's going to be all about a big, clear one. So this one is big and clear. It is D as in dog. All right, here's another one, SCAEC, so still in the level easy category, or level easy, and category C within it, type C, and that's all about finding line of best fit from a graph. The scatterplot shows the relationship between two variables, x and y. A line of best fit is also shown. Which of the following equations matches the line of best fit? Again, compare the values they give us, negative 25 plus 1.5x, negative 25 minus 1.5x. So I can see it's a negative slope, so it has to be either B or D. And then it has a positive y-intercept, so it has to be D. All right, so that is just clean and easy. They shouldn't take you more than 30 seconds. This is just about getting confident and understanding what they mean by line of best fit and how to approach the answer choices. A lot of these questions are about dissecting the differences and similarities within the answer choices. Then we have this one, SCAED. The scatterplot shows the temperature in a room after 12 p.m. A line of best fit for the data is also given. What temperature is predicted by the line of best fit for 8 hours after 12 p.m.? So this is about using it to get real world data. So 8 hours after 12 p.m., that's going to be here. So by the line of best fit, so don't go with the dot there, which is going to be around 15. Go with this, which is 20, B, because we're interpreting based off line of best fit, not the actual dot. So that's what's predicting it, is the line of best fit. Okay, if you get that, you'll be golden. These questions, I want everyone to be nailing. There's no reason why you can't get these. Besides, rushing or making mistakes, and you don't need to rush and make mistakes. Okay, so this is about interpreting a real-world situation. A scuba diver rises from a depth of 30 meters to a depth of 10 meters at a constant rate of 2 meters per minute. What type of function best models the relationship between the ascending scuba diver's depth and time? A key word here is constant rate, so I guess a key phrase, because that tells us it's going to be linear, and then it's ascending. So if we think about it, it's negative 30, but it's going up. So it's going to become less negative. So I would say it's increasing linear, C, okay? If you understand that, you'll be great. There's a lot of questions like this, not just in Scatterplots, but in other sections we have to interpret the data. But in the Scatterplot section, they might be specifically asking about what type of graph you would be making, what type of function. Then we have this here where we're interpreting a nonlinear graph, SCAEF. The graph to the left shows the relationship between the days since a baseball card was first opened and its price in dollars. Approximately how much more expensive is the card on day 14 than on day 8? So we look at this. Day 8 is around 50 bucks. Day 14, it's around 180. So you would do 180 minus 50 and you get 130. Now, I don't want you writing this out like I just did. I want you doing that in your head. Make it nice, clean, and easy. I'm just writing out to show you the way I would work it out. But it's in my head that I would do it. I wouldn't be writing it. Then we have this, SCAEG, SCA-EG. The scatterplot shows the relationship between the two variables, x and y. Which of the following graphs shows the most appropriate model for the data? So we have this. And then which of these has the line that fits better, right? It's not going to be B, it's not going to be C, and it's not going to be D. It's going to be A. It follows it nice and clean. That's the line of best fit. Okay. Again, this one almost feels intuitive, but it's still a category. It's still a type of question that SAT has that people could mess up on, so I want to show you how you would do it. You just try to find the line that follows most naturally. It could be something, if it was more like this, right? The dots are more like this. Then it could be something like C, but that's not like that. It's like this. A straight line could be formed. Now we're moving on to level medium, and we're starting with this one here. Scatterplot M type A, and this is all about using this when it has weird axes. By weird axes, you would think it would end on 0, 0, but the y-axis, actually the bottom of it is 86, so it's deceiving. The scatterplot shows the relationship between two variables x and y. A line of best fit for the data is also shown. At x equals 9, which of the following is closest to the y value predicted by the line of best fit? So we go to 9, we go here, and we get around 103.5. It'll be B. And that's all there is to it. It's just confusing because the y-axis is a little bit funky. But other than that, it's a clean one. And now we have this one. The scatterplot shows the price of a certain stock in dollars for the first 8 months after it opens one day. What was the average rate of change in dollars per minute of the recorded stock? Price from x equals 5 to x equals 7. This is about finding rate of change in something that's not linear. So at x equals 5, we're at around stock price of 5. When x equals 7, we're at around stock price of 14. So now it's like we do the slope equation. So we would do y1 minus y2 for x1 minus x2. And on top, we're going to do 14 minus 5 over 7 minus 5. We'll get 9 over 2. That'll give us 4.5. We'll get B as in boy. Okay? Easy peasy. It's just about plugging in the points. There's nothing more complicated about that. So it's called medium, but I think if you work on it, it should be easy for you. Now this one here, SCA-MC, is all about interpreting line of best fit without using the math. So the scatterplot shows the relationship between two variables, x and y. Line of best fit is also shown. Which of the following is closest to the slope of the line of best fit shown? Okay, so if you look at this, it has to be positive, so it's not going to be A or B. And now let's look when we go from 1 to 3. we're going from 5 to about 10. So it's bigger than one slope, so the answer is going to be D, 3. And the tricky thing here is that the scaling is different, right? Here we're going up by 1, so we're going up by 5. So it almost looks like a 1/3 slope, but it turns out to be a 3 slope. So always read the axes and the scales, okay? That's very important for any graph question. Now we come to this one, SCAMD, where we're comparing two types of functions. For which of the following is true about the values for 4x plus 3 and 3 to the x for x is greater than 0? For all x is greater than 0, it is true that 3 to the x is less than 4x plus 3. For all x to the 0, it is true that 3 to the x is greater than 4x plus 3. There is a constant k such that if 0 is less than x, which is less than k, then 3 to the x is greater than 4x plus 3. But if x is greater than k, then 3 to the x is less than 4x plus 3. We'll get to what that means. D, there's a constant k such that if 0 is less than x, and which is less than k, then 3 to the x is less than 4x plus 3. But if x is greater than k, then 3 to the x is greater than 4x plus 3. So we can eliminate a and b because that's just not true. Let's plug in, let's say 1. Okay, so in the first equation, we would do 4, 1 plus 3. In the other equation, we would do 3 to the 1. This would give us 3. This would give us 7. So b is not true because it's not always bigger. 3 to the x is not always bigger, right? We just found a time when it's smaller. Now let's plug in a different value like 3. And then we would do 4 times 3 plus 3 equals 15. 3 to the 3 equals 27. Now this one's bigger. So it can't be that it's always smaller, right? So there's been this flip going on. Now C and D, in a very convoluted way, are basically saying there's going to be a flip. There's this value k, at which point it goes from 3 to the x being smaller, right? Because it started off smaller, to 3 to the x being bigger here. So it should be D. K, at some point, there's this flip at k where it goes from the exponential equation being smaller to the exponential equation being bigger. Okay, so this one, you just have to compare them. You could plug in values to see, and you should know basically if 3 to the x is going to grow faster than a linear equation eventually. So if it starts off smaller than it, it's going to overcome it eventually. So the only thing you really have to check is to make sure 3 to the x is less than it originally. So that's it. If you have questions on this, you know where to reach me. In the comments below. A painter paints rooms at a constant rate throughout the day. He starts with a certain number of rooms he needs to paint for that day. What type of model is best to model the number of rooms remaining for the painter to paint that day? So this is similar to the earlier one we did with the scuba diver, except this time we're not given values. It's more abstract. We have to still find a way to do it. An exponential growth model, an exponential decay model, a linear model with a positive slope, a linear model with a negative slope. So again, there's that phrase we love to see, constant rate. He starts with a certain number of rooms he paints for that day. What type of model is best to model the number of rooms remaining for the painter to paint? So as he's painting, there's going to be fewer and fewer rooms for him to paint. So it's going to be a linear model with negative slope. Because let's say we had this chart right and he had 5 rooms to paint at the beginning. He'd be going down bit by bit as he painted them. Does that make sense? So it's going to be D. Constant rate. Watch out for those words because that tells us it's going to be linear. And now we have this beautiful one. The scatter plot to the left shows data for the amount of sales at a store, recording only certain days across a 20-day span. It also has a line of best fit. For how many of the 10 data points is the actual sales greater than the predicted sales? So this is about comparing the points we have on the scatter plot to the line of best fit. So how many times of the 10 data points is the actual sales greater? So the actual sales are the dots. The predicted is the line of best fit. So we have 1, 2, 3, 4. So our answer will be B, as in Battlestar Galactica. A great show if you've never seen it, you know, great sci-fi show. Then we got scatterplot MG. Each dot in the scatterplot to the left represents the distance y on a downhill ski race and the time x in seconds. The graph of which of the following equations is a line that most closely fits the data. So this is similar to what we did before, where we had to graph it, but we're not graphing this time, we're imagining it. So let's look at the differences here. 90, 90, 78, 78. So I would say, and let's look at this, right? We're starting at 84, we're starting at 0 for the x-axis. What do we think is going to happen? So if you were to imagine a line, right? Let's do a very funky line here. It'd be something like this. Okay? So already I could tell that it's more closer to 90 than to 78. I'm going to say it's not C or D. And then what's the slope, right? Well, let's say we're going from here, which is around 98 and 5. And then we go to 10, and that's at around 106 and 10. So we've gone up by about, 10 minus 5 on the bottom. And on top, we're going to have 106 minus 98. So we're going to get 8 over 5, which is approximately 1.5. So it's going to be B as in boy. Now what you could also do is plug in some points. When you draw the line, you could plug in a point like this and see which one it works for best. And then you'll be totally fine. You'll be moving and grooving. You'll be loving it. So it is B. I think this one is starting to get harder for people. But as you can see, it's not too bad still. You just have to read this, compare the values here, and not get overwhelmed. Don't get overwhelmed. You don't need to get overwhelmed. Now we have SCA, MH, and which of the tables to the left is the relationship between the X and the corresponding Y values linear? So here we're comparing charts. So linear means it's going up by the same amount every time. Let's look at A. 1, 1. So when we go up one here, we go up one here. Okay. When we go up one here, we should go up one here if it's going to be linear, but we double. So it's not linear there. This one I go 1 by 1. So then if we go up here 1, we go up by 2. Okay, that's fine. So we should go up here 1, we should go up by 2 here, we go up by 4. Nope. Then here D, this one has ugly numbers, so I'm just going to leave that one alone. We go up by 1, we go down by 4. That's okay. A linear relationship can be negative. Up by 1, down by 4, up by 1, down by 4. It is D. See what's going on with C. It is dividing by, I think, 1.5 every time. But we don't need to know that. It's just going down by different amounts, even though this is going up. And see how they make it clean with us? So it's 1, 2, 3, 4 on the x's, and the y's are the thing we focus on. Okay, so it's still not too crazy. Even though there's a lot of numbers to look at, it breaks down nice and cleanly. And you should be nailing this one. It's about using a chart and seeing what type of functions are in those charts. So here we have the scatterplot shows data about a town's population in thousands between 1900 and 2020 with random years recorded if the trend line is accurate across the 120-year period. And its equation is y equals 0.5655x plus 10.641. In thousands, what does the line of best fit predict about the increase in the town's population over the 120-year period? A, each year between 1900 and 2020, the average increase in population was 565.5 people. Each year between 1900 and 2020, the average increase in population was 0.5655 people. Every 5 years between 1900 and 2020, the average increase in population was 565.5 people. Every 5 years between 1900 and 2020, the average increase in population was 0.5655 people. So the slope is this here. So this is asking about slope by doing this, the average increase thing, right? But I said when I was reading it, I said in thousands because I was thinking about it out loud. I should have just read it. But what we see is because we're told it's thousands, this is really talking about things in thousands. So it's not going to be B because that's just people, and D. We're between A and B. What's the difference? This one's saying every 5 years. This is saying each year. The answer should be A. Each year there's an increase of this amount because we never told that X is for every year or something like that. So the every 5 years is here, but the slope itself is talking about it in yearly rates. All right, so that should be good for that one. Okay, now we have scatterplot HB. The scatterplot to the left shows a lemonade stand sales S and the day's average temperature T across multiple days A line of best fit for the data is also shown. Which of the following could be an equation of the line of best fit? A, S equals 3.5 plus 214.72. B, S equals 0.35t plus 214.72. C, S equals 3.5t plus 175.72. And D, S equals 0.35t plus 175.72. Now notice here that the scales are different on the y and the x. This is going up by 10 every little dash. This is only going up by 5. And also they both start at random numbers. They're starting at 10 and 195, not 0 or 0 for either one of them. So first let's focus on the y-intercept. It looks more like it'd be hitting at 214, but the y-intercept would be when it's 0. So this one here isn't when it's 0. So we'd have to keep going, and it'd be going sort of beyond this. And you could even plug in a point like this here at 20, 245. If we plug in 20 and 245, right, which of these makes the most sense? It would probably be C, because we would do 3.5 plus 20 plus 175.72. We would get 70 plus 175.72. We would get 245.72 when it's 20. So C should be the right answer. It's definitely not A and B because it's going to cross at this other point, and then it's not D because the 0.35 is not the right slope. You could also look at the slope first if you wanted to, and see how when you go up by 5, you go up here by almost 20. So you're going up by 3 times that amount, more than 3 times the amount, so it has to be 3.5. So our answer is C. What really throws people off is they would choose A because they're just like, oh, it's hitting at 214. No, my friend. It's hitting at 175.72. Then we have this one here. The scatterplot shows the relationship between the distance run y by a certain person on days since January 1st, x. What is the average rate of change in kilometers per day of the distance run by the person on January 3rd to the distance run by the person on January 8th? So, days since January 1st, so January 3rd will be 2 days in, so we're going to use this point here. January 8th would be 7 days, so we're going to go here. And what we do is we do the rate of change equation. So we're going to do 14 minus 3 over 7 minus 2. And we're going to get 11 over 5. Okay, what makes this one tricky is counting the days correctly because it's January 1st. So 3, you might go to 3 automatically, but it's just 2 days. And then again, remembering average rate of change, doing this equation. But other than that, it's not too bad of a question, even though they label it as hard. And now we have Scatterplot HD. The scatterplot to the left shows the amount of sales at a soup stand month by month for a given year. Of the following equations, which best models the data in the scatterplot? Okay, again, we're not starting at 0 on the y-axis. We're starting at 100. We have all these. So first of all, is it negative or positive x squared? It's positive because it's facing up. It's a curving up like this, right? So it'd be a bell, be U-shaped instead of bell-shaped. So we can eliminate A and C. And then, beautiful, beautiful, beautiful. What about the y-intercept? It's positive 118, so it has to be D. I didn't even do any math. How is this hard? I'm just kidding. It is hard. It is tricky to think about. But you can see you don't need to do calculations. The problem here is people aren't confident and they waste time on this question. But if you're confident, you'll nail it. The scatterplot to the left shows the relationship between 2 variables, x and y. Which of the following could be an equation for the line of best fit for the data? So here the data is all clustered together, all the way from the axes. But again, if you drew it out, what would it look like? You'd be drawing it out this way. It'd be hitting around 123, so it's not going to be A. Now, what's the slope? Right here, when we start at like 6, we're at a little bit above 500. At 7, we're a little below 600. So the slope has to be less than 100. So it's not going to be C, it's not going to be D, it's going to be B as in boy. Does that make sense? You want to use the answer choices. You want to be using the answer choices and approximating to save yourself time. I think a lot of these, the thing is that people waste time by hesitating and not trusting themselves. For x is greater than 0, the function f is defined as follows. F of x equals 27% of x. Which of the following could describe this function? Okay, so this one is about, again, we've had a medium level, we've had a hard, easy level. The easy was like the diver. The medium level was the painter. This one is just pure abstract value. So it's going to be f of x equals 27%. We're going to make that into 0.27x. What does that look like to you? Because it's of is multiplication. That is positive, so it's increasing linear because it's not to the x. If it had been 0.27 to the x, then it'd be decreasing exponential, but it isn't. It's just d as in dog. So if you have questions on this, please feel free to ask me and I'll explain more, but I think it makes sense. The of is really key there. So then we have this one here, SCAHG. Kevin and John invest their money in different accounts. John's account has an annual interest rate compounded once per year. Which of the following is true about Kevin and John's investments? So initial amount for John is 1,000 and he has a 4% annual increase. Kevin has 3,000 and he goes up 60 per year, just a regular 60. A, John's account is always earning more than Kevin's. B, Kevin's account is always earning more than John's. C, John's account initially earns more than Kevin's, but eventually earns less money per year than Kevin's. D, John's account initially earns less than Kevin's, but eventually earns more per year than Kevin's. So the only real question here is, does John earn more than Kevin at the beginning? Because he's exponentially growing and he's getting the same amount every year, eventually John will overtake him because exponential growth is going to beat linear growth eventually all the time. But did he start off earning more? So in that first year, how much did he earn? He did 4%, so we're going to do 0.04 times 1,000. And that's going to be, you could think about it as a fraction we want, 4 over 100 times 1,000. 2 zeros cancel, so 4 times 10 is going to be 40. He earns less originally, but then he eventually earns more. And we don't have to check when he earns more because we know it's going to pick up. You could check the next year and see because it's going to be 1,040. He'll earn 4% of 1,040 instead of 4% of 1,000. We have this one, scatterplot, category H within level H. The scatterplot shows the relationship between two variables, x and y. An equation for this exponential is shown and can be written as y equals x m times n to the x, where m and n are positive constant. Which of the following is closest to the value of n? So this is an exponential equation we're being given here, right? M is the initial value, n is the amount it's growing by each time. So if we look at 2, right, it's somewhere below 10. And then if we look at 4, it's still below 10, but it's gone up. Now, it has to be B. It has to be B. Because A would be a decreasing exponential because it's less than 1. C, after one jump, it would multiply by 13. So we'd go from this all the way up here. We'd be jumping up. D would be even a higher jump. This is a more steady growth, so it has to be B. Did I do math? No, I just read the choices and did process of elimination. If there had been another answer that was like 1.4, then I'd have to do math, and they wouldn't ask a question like that. Because we don't even know the actual values here, we wouldn't be able to figure that out. The numbers are starkly different. And that is the last one I have for you all. If you have questions on anything, easy, medium, hard, please leave a comment. And remember, I have in the description a link for my Substack that's totally free and available for everyone, where I am categorizing questions, breaking them down by type. I'm going through the College Board question bank, categorizing them so you could type in the ID number of a question, find it and be like, oh, that's what this type of question is. Because then you can build connections in your own mind, see how things are working, and really build up and grow fast on the SAT. So again, I hope you enjoyed this video. Remember, I've done one on percentages and probability and conditional probability and a whole bunch of things. And I'll be doing more and more as the year progresses. And if you have anything you need me to help you with besides the stuff I've already done, feel free to reach out to me. Otherwise, I hope it's sunny where you are, but if it's raining, I hope the rain is cleaning your windows and watering your plants. Bye.